Hello, everyone, and welcome to my talk at SauceCon. And thank you for taking some time for SauceCon and for talking to me. My name is Paul Grizzaffi, and I'm going to be talking about automation, concurrency, and making sure you don't step on your own toes. So, I'm a principal automation architect at Cognizant Soft Vision, and I've spent it's been a long time now, almost 30 years of career on automation, testing adjacent, automation adjacent activities. Um, I'm an advisor to STPCon, which has now sort of taken a track in the InflectraCon, which is basically now as well, um, and for the Software Testing and QA Center at University of Texas at Dallas. If you are interested in contacting me outside of this particular forum, here's my contact information. And that link at the bottom there is my link to my blog where I have certain thoughts that I hope are largely cogent regarding automation and testing and sort of related things there. So, if you've seen me speak before, I'm not much of an agenda guy, so we're just going to jump right on in. And when we talk about automation and concurrency, we don't just walk in and say, "Today, I'm turning on my parallelization." Boom, everything's in parallel now, and it just works. Unfortunately, it's not that simple. There are a lot of considerations that we need to take, and it's a non-zero amount of work to get those considerations taken care of. The main thing we're looking at here is failure due to improper concurrency or improper parallelization. Because we all know about intermittent failures, right? And even if we've gotten all of our automation, we've shaken it out, and all the intermittent failures, all the race conditions, all that stuff's handled now, right? We start introducing parallelization, and we can start seeing those types of problems again. Different causes, admittedly, but still different problems, because as you can see on this slide, the results of that run are different from the one we had before. So we have to be careful not to shoot ourselves in the foot or chop off our toes with the axe there, Eugene, for all my Pink Floyd fans. We have to be careful. We have to be cognizant, no pun intended, of the relationship that our code has with the environment in which it operates and the environment in which we test against. So again, in the spirit of jumping right in, one of the first things we need to talk about are threads and concurrent processes. So threading is what a lot of automation tools will use to provide the concurrency for you. Threads are basically a lightweight way to run multiple code flows at the same time. Basically, concurrency and parallelization. It's very powerful because they are lightweight. I'm not going to get into the very specifics because different programming languages and different operating systems handle these things differently. But at the core, it allows basically the same code to be executed at multiple different times in multiple different places. And when it's multiple different places, it's generally not a problem. It's when it's multiple times in the same place, in the same piece of code, because that's where we potentially find some problematic areas. And our code must be what's called thread safe. And we'll talk about thread safety here in a second. But not only must your code be thread safe, the code that you use from your vendor or from your other teammates or from open source libraries and free source libraries, it must all be thread safe as well. Otherwise, we start running into problems. A way to handle some of the issues with thread safety, but we still have other issues as well, is concurrent processes. Now, this is a much heavier weight way to go. Your machine would need much more processing power. And it does not eliminate the external dependencies. So if we are dependent on, let's say, a database or a file on the file system, then concurrent processes are not going to do anything to help you out with that. And this is not typically how things are done anymore. Back in the before times when I was dealing with concurrency and running multiple test scripts or test cases and multiple pieces of automation all at the same time, threads weren't quite as grown up as they are today, and they weren't as, I don't want to say they weren't as reliable, but they were limited in what we could do with them, or perhaps our understanding of how to use them. So we went with concurrent processes, and of course this is back in the mid 90s. So things have changed much, much for the better since then in some of these computing environments. So again, this is not what most teams do today, but it might be an option if if you've got the facilities to do it. So in the previous slide, I did talk about thread safety. So what is thread safety? It's basically a safe manipulation of shared resources, and generally it's shared data. Because even if you're dealing with a shared resource, you're either putting data onto it or getting data from it. Getting data from it is usually not a big deal. Multiple readers, when we talk about multiple writers, going back to the reader-writer problem and the reader-writer example, the safe manipulation of that data, the changing of that data can be difficult if multiple threads, multiple people, multiple writers are attempting to write all at the same time to that particular space where the data is stored. And there are a lot of methods to handle methods to handle thread safety, some of which are reentrancy. Reentrancy is the notion that a function, a method, and a member function, whatever your vocabulary is for a re-executable piece of code, is that if it were to be re-entered by another thread, in other words, my thread is running now, but another thread is also going to be running potentially in that same piece of code at the same time, is anything being done in that particular function or block of code that would step all over each other. Making your methods and your functions such that they are reentrant will eliminate or at least greatly reduce any sort of issue that you would have with threading there. Not everything can be reentrant, so we have to be careful, and fortunately we've got other pieces of programmatic capability to help us with some of that. Immutability, so if something is immutable, it means it's unchanging. So if we have immutable objects, read only, we set it once at the beginning before threading happens, possibly at program startup, but certainly before any multiple threads might be running. It's set, it's done. You cannot change it. So an example might be like a programmatic constant. We set it when we create an instance of a particular object, and then it never changes, so it doesn't matter how many concurrent threads go and try to read that piece of data. It doesn't change, so it's always going to have the same value, and there's no concurrency issue there. Mutex, or that's a short for mutual exclusivity. The idea of creating a block of code that says this block of code can only be executed by one thread at a time. So what you effectively do is you queue up other threads while your primary thread or your current thread is working in that block of code. Then when that thread exits that block of code, the other threads, the next thread, is the next candidate to go and execute that piece of code. And I'm greatly simplifying a lot of these things because some of which I'm not as up to date on some of the operating system implementations as I used to be, but also it's a very deep working and set of knowledge you need to explain a lot of the underpinnings there. But what you need to know is that you can set certain pieces of your code to be basically uninterruptible. They are mutually exclusive. No one else can enter that piece of code while one thread is there. And then related to mutual exclusivity, you can set atomic or non-interruptible methods or functions and say, this function is not interruptible. Once a thread starts executing this function, this thread will finish its execution of this function before any other thread can get in there. And these are very powerful ways and very effective ways for you to make your code thread safe and protect yourself from concurrency intermittent failures. So when you do work on this and you build your own code this way, but make sure you find thread safe libraries and thread safe data structures. A lot of times in the documentation, it will say it's thread safe or that it's not thread safe. If it doesn't specifically say it, you might be concerned that it is not thread safe and you should keep on that piece of code. And into each life some rain must fall, we have to be aware of something called deadlock. And deadlock is when something like thread 1 is waiting for something to happen that thread 2 is going to cause to happen. But thread 2 is waiting on thread 1 to finish. So they are deadlocked. Neither can finish because they're each waiting on each other. So we have to be very careful with that, and dealing with mutex and atomic methods can get us into a deadlock situation. Fortunately, in automation, test automation, what we typically do is if you're using a library that's thread safe and you are using an established sort of method of doing work, you're using Selenium, you're using Microsoft Test, or you're using JUnit or whatever. Those things are going to be largely thread safe, and the things that aren't will be called out for you. So you can figure out where your safety is going to be there. So that's the programmatic aspect, and the programmatic aspects are icky, but because of the world that we as automation creators, or at least most of us do, because most of us are not creating our own tools, and we're not creating our own entire platforms to do multi-threaded execution. We're usually using somebody else's that we've downloaded or that we've purchased, and that stuff's largely handled for us. But if we are creating and doing some, say, out-of-the-box stuff or corner case things because what's provided to us or available to us today is not fitting the need, is not appropriate for us, we could run into these issues, and that's why I like to bring these up. The rest of the issues that we're going to talk about are things we really do have to think about, even if we're working in a thread-safe environment. So what about credentials? Do you have enough? And what I mean by do I have enough, or do you have enough, is does your application require logging in? If your application requires logging in to do anything or anything interesting, or there's a large portion of what you would want to do you need to be logged in for, perhaps you need multiple credentials, one for each of the concurrent test scripts you're executing. Because in some cases, you can't log in more than once to an application with the same set of credentials. Or perhaps you can, but you can't do it from the same machine. And even if you can, if your application allows you to do it, if you're running 2 test scripts working on that same data set, could they be corrupted? And when I say corrupted, I mean put in a state that is not conducive to any other test scripts passing because of the concurrency. Is there anything that's going to be set up that way? And if you do need concurrent, or you do need multiple credentials, how hard is it in your organization to get those credentials? Some organizations, and especially some product implementations, it's not a big deal because they haven't been tied to an external piece of authentication or authorization functionality. Like it's not tied to Microsoft Active Directory, or it's not tied to Okta, or any of those things there. In cases where the auth and the authorization and the accessibility is all built into the application itself, then adding new IDs, new users, new whatever, not typically a big deal. If you have to go through your corporate security or corporate IT to get additional credentials, a lot of times you're going to get the fish eye, right? You get the stink eye that says, Oh, yeah, that needs to be assigned to a user, and each user can only have one ID. And wait, what do you mean? You need 400 of these things. Um, Keep that in mind that while you can potentially work through these items, you can't always just turn on concurrency and say, now we are concurrent. And then there's the data. We talked about the data a little bit earlier as well. When we do have data, we have data that is largely transient in a lot of our worlds, right? Especially if we're looking at, let's say, a flight system or a reservation system where you have a reservation, perhaps you modify it, then you execute the reservation, or the flight takes off and now the flight's gone, so the reservation is done, right? I mean, you've used the ticket and you've exited that part of the system. You need enough data to be able to execute all these things concurrently, because as we know, managing data is a pain in, well, places that most of us would have rather have less pain than more pain, right? It's just painful because the quantity of data we need to be able to do our jobs, our testing jobs, is large, and it's getting larger as our systems become more complex. And necessarily so because they're mirroring complex events and complex activities in real life. So each potentially concurrent test script might need its own data, because if you're if you're working on the same type of data, let's say you've got a test script that wants to create a reservation and have it successfully go through, and then you want one where you give the same kind of information, but you want it to fail. And you've set it up to fail somewhere along the way because you've given it some bad data, or you've gone and tweaked the data in the database such that it is now invalid to perform whatever operation you want. That tweaking in the database or the data store could adversely affect the other script that is also attempting to run at the same time. So you might need separate sets of data for all of this. And inattention to test data can absolutely cause inconsistent behavior. And as we know, inconsistent behavior in test automation leads to intermittent failures, a lack of trust in the automation, and then lots of the gnashing and the rending of the cloth in the teeth, right? And then there are the execution environments. All this stuff has to be executed somewhere, right? So we need enough horsepower. In some cases, we want to run all of these multiple threads or multiple processes on one machine. That doesn't necessarily work. We may have to have off-board or remote execution from wherever we have the initial test infrastructure set up. Now, for GUI testing, managed grids and managed devices can help. So companies like Sauce Labs provide these managed grids and device farms and such that you can connect to. So the management of that hardware, it is not free, but you don't have to do it yourself. You just have to configure your automation and your data, of course, to be able to work concurrently. So we have to keep in mind that all this stuff has to run somewhere. Where is it going to run? And that's for GUI-based automation. What about your non-GUI based automation? Hey, we're going to run a whole bunch of web service, a bunch of JSON puts and gets and posts and all that stuff. Awesome, cool. Threading there, pretty effective because it's fairly lightweight. If you build your code reentrantly, awesome. However, you still run into these data issues that we talked about on the previous slide that you have to manage yourself, and you have to make sure that your execution environments, your horsepower, can manage the multiple execution streams that you're running. And then I argued with myself on whether I should put this at the beginning or at the end, but I decided toward the end was better as sort of the oh, by the way kind of thing. Tool support. Does the tool that you're using even support parallel execution? You know, if you're building your own automation, let's say with a programming language and using JUnit or MS Test or InUnit or XUnit, yes, it supports parallel execution. Not all vendors that I'm aware of support parallel execution. It's getting better. Some of the vendors that did not before do now, but does it require additional licenses? Or is there a need for you to purchase additional execution capability because while I want to run these things in parallel, frequently they are cheaper to buy these execution licenses than the actual development licenses, but you have to figure that into your value proposition and make sure that running in parallel provides enough value for you to pay for the extra licenses. And in most cases it will, but it's an exercise you have to go through. And then what are the logistic aspects of running in parallel? Can you run in parallel on a single machine or must you use multiple machines? If you must use multiple machines, then what's the licensing agreement and the cost per core, cost per processor, cost per user, whatever that is from a license standpoint? You have to think about that when you figure out all your parallelization and your monetary outlay. So really, and those of you that have seen me speak before, um, I talk a lot about being appropriate because what's appropriate for one team or one organization, even in the same company, might be different from another team or organization if they are working on a sufficiently different application or a sufficiently different product. So when we talk about concurrency and parallelization, our runs only need to be fast enough. Now, what's fast enough? For some teams, I need all of my automation, whatever all means, to run in 5 minutes, or I need to run in 2 hours, or I need it to run in 3 hours. So if you can get it to run under your minimum barometer or your maximum barometer there, your water line, then making it faster than that may not be economical to provide enough value. So don't over engineer what you're doing. Think about what you need, think about where you need to be today. And I forget what the exact quote was, and I forgot even who told it to me. But basically, what we need to do is we need to plan globally and implement locally. So we don't paint ourselves into a corner. We don't create something that is going to be a huge earth lift just to redo. What we want to do is we want to plan for evolution. Don't preclude ourselves from making valuable changes in the future, but don't implement all the other things because you get the YAGNI, right? The YAGNI, that you ain't going to need it. Um, a lot of things we think we're going to need, we just don't because the business case for it never comes up. So don't over engineer what you're working on. And like I always recommend in all things, start with what's appropriate and then evolve. But make sure that when you implement appropriate, that you haven't really precluded yourself from being able to evolve. Because I mean, my old automation lab at another at another job that I had was this, and I said that's about a third of it. We repurposed a bunch of laptops that were going to be going to the recycler because they just needed some horsepower, and it didn't matter if they weren't the fastest and didn't have the most memory. I was going to run one browser test at a time on each machine. So we basically set up our own grid, if you will. The tool that we had at the time did not support the Selenium grid. We weren't using Selenium. So using the out of the box grid didn't work. So we home grew some stuff for this data migration. I mean, this data center migration activity that we're working on, and we used these 32 old laptops and got the job done. So be appropriate, be creative, use your mind. It doesn't all have to be threads and cloud and all these other things until it needs to be, right? Do things exactly when you need to, not before and not after. So just a handful of takeaways here for you. When we are talking about concurrency, make sure we are using software that is thread safe and creating software that is thread safe. Make sure that we have appropriate environments, execution environments, data environments, all these other things, because the data does matter. We have to make sure we have enough data, it's appropriate, it's segmented off appropriately, and that we have enough credentials. Because I actually worked on an application one time where we could have as many logins with the same ID, even from the same machine that we wanted. But what happened was a timer started on the first login. And when that timer expired, all the other logins, because they were all tied to the same ID, they all went stale at the same time. So the next operation you would execute, you would get this cryptic error message about not being logged in anymore. When obviously you were, but no, you really weren't, because the timer got set on the first login, not on the last login. So we needed additional credentials to make sure we didn't time out there. And again, thank you for your time. Thank you for your attention. I hope you enjoy the rest of the conference. Again, here's my contact information. Have a great day. Have a great conference.